Hi, everyone. Thanks for joining the Road to Six-Figure Data Science Job with Richard, where we make poor Richard into rich guy. So today we're on episode 6. We're talking about Python and benchmarking Richard's skills here so we can set him up with a basically a grind plan for the next couple of months on getting better at Python algorithms and also SQL. So Richard, how are you doing?
Doing pretty good. I'm excited for the end of this month. It's the final month of school, so looking forward to a few weeks of break. Working on projects right now for class, struggling through those, and then trying to practice these Python SQL questions. But overall, like you said, the grind is grinding.
The grind is grinding. All right. So today we're going to go over a problem called weighted keys. So I think, Richard, you need to share your screen.
All right, weighted keys. Given a dictionary with weights, write a function random key that returns a key at random with a probability proportional to the weights. For example, weights is a dictionary. Key A has the value 1, key B has the value 2. And for the outputs, we return A 1/3 of the time and B 2/3 of the time. So it seems here that I need to create a bag that is representative of these weights and then randomly choose from this bag. So in order to choose randomly, I would use the random package. And then to create the bag, I would just initialize an empty list and then iterate through all of the items in the dictionary. So for key value in weights.items, we will append a key into the bag value number of times. So I would say another for loop. So for range value bag dot append key. By doing this, we'll have the number of keys in the bag. And then once we finish creating this bag, we just do random dot choice key. And that is what we're going to return. All right, let's give this a try. This did not work.
Nope.
Whoops, I meant bag. There we go.
Oh, I try submitting it.
All right.
Okay. So let's go through your code actually, because I'm a little confused because you're just adding the key, but it doesn't matter what the weights are. I thought we had to return it with a proportion to the weights.
Well, every time you run this function, it's going to return a random key from the bag.
I see what you did. Okay, yeah, you appended it 2 times. Okay, gotcha. So essentially how it works, right, is that every single time you add the weight that certain number of times into the bag. Okay, what's the runtime of this?
It would have to run O of n times, where n is the sum of the weights in the bag.
Yeah, so that's not great, right? Because let's say A is 1,000, B is 2,000. Technically, n is equal to 2 here, but then you would be turning n into 3,000 through your code, right?
Right. So
Same
we
with if A
probably,
is like 1 million, B is like 2 million. Is there any way we can make it like a little bit more efficient?
I'd say this inner for loop could probably be changed to some other function that replicates k v number of times. So let's
As a
see.
proportion, right?
Yeah. Can you just multiply lists by an integer and it would replicate the items that many times?
Maybe you could test it.
All right, let me try. So let's say temp equals a single list with key in it. And then we do temp times equal. Okay. This doesn't seem like it'll work, but let's give it a try.
Okay.
Yeah, that is not correct.
Okay. What else could you do? What about scaling it down for the proportion?
So finding like the greatest common denominator of each weight and then
Yeah, that could be one option. Or the fact that, like if it's 1 million and 2 million, that you can bring this down to 1 and 2 by potentially saying that A is 1/3 of the total, correct?
right. Yes. So I'd still have to iterate through the whole dictionary, then add all of the keys together and find out the proportion of each.
Yeah, but instead of iterating through each weight, you then just have to iterate through each value. So it'd be actual O of n versus O of n plus m, which is I think what yours is, where m is basically the dynamic value of each one of these weights.
So in that method, we'd have to have like a temporary variable holding the total of each weight. I'm not sure how I would implement that.
What do you mean?
So you're saying that we have for each key, we have to find the proportion of the total, meaning we have to get the total first.
Yeah, you have to find the total first. Okay, so how do you find the total first?
I would say total equals sum. I'm going to use a list comprehension. I'm thinking sum of value, sum of I for I in weights dot value. Pretty sure that would work. It does not work.
What does it print?
Nothing. There's an error. List index out of range.
Okay, so I think you can actually just sum the weights values. You don't even need to like for loop through them. What line of code is it giving you the error on? It says list index out of range. That might just be some of the code. You should just probably comment that out.
Oh, I think it's this, the random not choice. So it's okay. So yes,
So that works.
okay, and then now iterate through the whole dictionary. So for key value, find the proportion of each.
So I think there's one way where you could scale it down, right? There's another way where you could just return like something random from this list without even using the random function, potentially, right? Like you found the total, now you have the proportions for each one, right? Technically. So how do you return like a random value?
I only know how to use random.choice.
Okay, but let's say you can't use random.choice.
How do
How
I
do you now return a random value, given you have a list of proportional weights?
I don't know. Do you have any suggestions?
Okay, so let's say that you have a bunch of items and you need to pick something randomly. How are you supposed to do that? You have a bunch of items in the bag. You know that you have different proportions of them in the bag. How do you pick one randomly?
I just pick. I mean,
Okay, you just pick. Okay,
with
but let's
code?
say that now you need a computer to pick. How would you get the computer to pick it? So you put your hand in the bag, you pick something out, right? Well, now you have a list. You need to figure out some way to pick one randomly. How do you pick one from the list without using random.choice package?
I don't know.
You don't know. Okay. What if you could like sort your list randomly and then pick the first one? Wouldn't that be random?
How do I sort my list randomly?
So you said you couldn't use random.choice, right? But you could still sort using random, let's say.
I pick a random index in that case then. I do like a random int with the range of the index.
Yeah, that works.
But in that case, I would still have to build a bag with all of the items in it, value number of times, right? It's not like a proportion then.
Yeah, it's not like a proportion. So you still have to build up your bag. Is there a way to do it without building up your bag? Well, let's say that you have like all your values, right? And you have the total. And what if you picked a random number? So let's say that the total is 1 million. What if you just picked a random number that was like between 0 and 1 million? So let's say 200,000. How could we use that number as a random number to return a weighted key back?
I would map like a certain range of that, 1 to a million to each key's proportion. So like if, for example, A was 1/3 of the bag, then 200,000 would turn A because that's between 0 and 333,000.
Yeah, that would work. So how do you map it?
I would multiply the proportion by the range of this random function.
Well, you don't even have to multiply it, right? Because technically the total exists as 1 million and then A is, let's say 300 and then B is 700. So you wouldn't even have to do like the proportion size. And you could just be like, okay, 200, how does that get mapped? Oh, that's between 0 and 300,000. So let's return this other.
So you just divide by the total.
Sure. Yeah.
Okay.
And we could do that with, let's say the random number is now suddenly 600,000. Okay, that's between 300 and a million. So let's return B, right?
Right.
So how can we do that within the ranges without maybe doing something complicated and specifying like beginning and end and all of that stuff? There must be something easier than doing all that.
So I think in that case, I'd have to build a new dictionary of proportions instead of a dictionary of weights.
What's a dictionary of proportions?
So like instead of A to 1, it would be A to 1/3, or I guess 1/3 to A.
I just told you that you have the total and you have these weights. And so in my example I gave you, it wasn't 1/3, was it? It was just 300K. We were like using actual absolute values.
Okay.
So technically you don't need it. Again, I'll give you another example, right? Let's say it's 10. The total is 10, A is 3, B is 7.
Uh-huh.
We choose a random number between 1 and 10. If it's 2, what should it be? What should we return?
A,
Okay. If it's 8, what should we return?
B.
Okay, cool. You could see you're calculating something in your head that is basically this function, right? So how do you like put that down onto a piece of paper so that the computer can understand it? If it's 5, what do you return?
B.
Yeah.
Wait, so are we specifying like the range between, you said the max is 10, right? Are we specifying the range of between 1 to 3 as A? So we still have to
Yeah.
tell it.
We are, right? But then what if you had like 5 different weights here? So it was like A, B, C, D, E. The total is 20. Then it gets a little bit more complicated. And specifying that range in your head is also a little complicated as well. I would say something easy that we could do is just like we could do some sort of running sum so that instead of specifying this, we just literally loop through A, B, C, D, E, F, and then keep on adding the values to it. And if our random number suddenly is lower than this sum, then we return the value, right?
I think I get it. Let me think about how to do this.
Yeah, you should get it because I just told you how to do it. All right, so you have it right here. So for K, V, and weights items.
So everything from 0 to A is A, and then for everything
Exactly.
from A to B is B.
So we have a random number and we're like, all right, is it less than the value of A? No. Okay. Is it less than the value of A plus B? No. Okay. Is the value less than A plus B plus C? Yes, it is. Okay. Then return C, right?
Yes.
Okay.
I'm not sure what data structure I'd use to store this then.
What do you mean what data structure you need to use?
Oh, you're adding every value associated with the key. I'm a little confused here.
So for K, V, and weights items, right? You're looping through A, B, C, D. So
Yeah.
first you need to initialize a random variable between 0 and your total. Can we do that first? That's our random number.
So before the for loop.
Yes, because this is the random number that we want to try to guess, right?
Right.
Okay, so let's say that that works. I don't know if that's actually accurate. Does it default to 0 on the bottom of the range for rand int?
I don't know. I'd have to look at the documentation.
Sure. Okay, so like I said before, right? I'll say it again. If it's A, then what do you return? If it's B, what do you return? If it's C, what do you return? Right? So it's 0 to 10. Let's say we have A, B, C. A is 3, B is 3, C is 4. So you just pulled a 5. What value should we return?
C?
Where did you get C?
Said 0 to 1 is A, and then B is 3, so 0 to 4 is
No,
B.
I said A is 3.
Oh.
A is 3, B is 3, C is 4. It adds up to 10. Okay, so you pull 5.
So it would be
Okay, but how did you come up with that?
A plus B. So R is less than A plus B.
Okay, cool. So how do you do that now in this? Before you did that, right? You checked A. Like you checked A, you're like, okay, 5 is not less than 3. So let me check the next one. 5 is less than 3 plus 3.
So I need a running total here.
Yes.
Is this correct? Let me see. Okay, I don't actually know what this is.
Yeah, I think you're just missing our range. So just add 0 and then a comma. Try that. Okay, so something's going on, which is wrong. Where did you initialize running total equals 0? Okay, you summed all the weights values. All right. And then for K, for the first one, you added the value. That looks right.
Less than or equal running total?
Yeah, it might be it. Look, you're like right off of the distribution.
Oh, definitely not. Is it this? This is how I normally code, by the way. I just try a bunch of things until I get the right answer.
I think it's probably worth just sitting down and thinking it through a bit more. Try submitting your solution. I want to see what all the different test cases say. So you passed 2, you failed 1. Okay. Try less than and equal again. So I think the only thing is that you are choosing an integer, right? And potentially the values that are coming up are not integers. The only thing is like, yeah, it might be continuous versus an integer, which is why some of these test cases are failing. The only way to get around that would be to scale it down between 0 and 1 so that you could get to those like very specific amounts. Because if you do like 3 out of 10, let's say you'd have to come up 30% of the time. But let's say that your input values, the weights and the values are not integers. So potentially they could give us some weird things because you're choosing an integer versus like the values that you're doing are like trying to get like 33% or something like that. Right. So then it wouldn't work as well in terms of the distribution.
Okay. So let me try that then.
So your random value also has to scale down between 0 and 1.
It wouldn't be rand int then, it would just be rand, I believe.
No, I think that'll choose between 0 or 1. I think it's just random or something. There's some other thing to go between 0 and 1. Not like no values.
This?
Yeah, try that.
Oh,
Okay, nice. Cool. Okay, we debugged this. Awesome.
okay. I don't think I would have figured out that integer issue on my own. But now that you mention it, yeah, you're right. It would be discrete between, like 3 out of 10 instead of 1/3, which is
Yeah, and the way I figured it out was just by running it on multiple test cases, and then you could see that you were almost there, but you had this like 0.05 off significance distribution value. Also show the viewership what we do for our users in terms of creating these amazing graphs for test cases. Like we literally model out the distribution for you on Interview Query. All right, awesome. That was a good first step. I think the main thing that you have to do, Richard, is just practice more and more questions. When we're talking about this curriculum, it's really just about practicing a certain amount of questions per week, right? And I think at least once per day is really good. So if you can just portion out like 30 minutes out of your day to practice one SQL question or one Python question, it'll be really good. So I think I would encourage you to try like 7 questions a week and then see how you progress from there on out. You could time limit yourself so that you don't struggle for more than like 30 minutes if you just want to like eventually get to the answer. But the struggling is where you learn the most, I would say. And obviously having someone here is helpful, but you can also use, ChatGPT as a personal tutor in a lot of these situations, especially if you just need it to like slowly walk you through something. Highly encourage that. Obviously, we also have hints and gotchas here on the left-hand side.
So I do have a question about coding practices in general. Like my first attempt was correct, but it wasn't the most efficient or optimal solution. Like in terms of, in a real interview setting, how much weight does that hold in terms of like just getting the answer correct no matter what method versus like a better method, say this runs in, O of n time versus like O of n squared or
it's just if they want to test to see what benchmarking your skill level, right, as an interviewer. So I did that just to test to see how quickly you could solve a slightly harder problem, right, when we remove random.choice.
Mm-hmm.
And a lot of people do that just to test like seniority of your skill level, right? Because the faster you can think through these added problems, the better of a programmer you should be technically. Right. It's just something that comes up. It showcases that, you're more of junior right now because it's harder for you to come up with these solutions. But again, as you see more and more different scenarios, eventually you'll understand and apply this to like harder algorithmic problems.
Would you recommend it that I tackle a problem once and then do it over again while trying to think of like a more optimal solution?
Yeah, I mean, you should always be getting to the best optimal solution in your mind, I would say. It's definitely worth doing.
Okay.
All right. Sounds good. So next week, we'll keep on having you practice Python questions. We might do SQL or Python or focus on a non-technical section instead, and then kind of talk more about the data science market right now. But thanks so much, Richard, and we'll see you guys later.
All right. Thanks, Jay.